In this video, we're going to explore the distributive property. Now, when we do this, we have to pay attention to our order because of the order of operations. Now, when we do this, we want to simplify everything inside parentheses first. Then we simplify our exponents. Then we do our multiplication and division left to right. And we do addition and subtraction left to right. Now, let's look at our example down here. When we see both addition and multiplication, we don't just work left to right. We have to pay attention to that order. So the first thing we want to do is we want to multiply 5 times 2. That'll give us 10. Now we can deal with the addition. 7 plus 10 is 17. If we had done it just left to right, we would have done 12 times 2, and 12 times 2 is 24. That is not correct because the order is not paid attention to, that order of operations. So make sure you pay attention to that as we do problems. Now with the distributive property, there's the combination of addition and multiplication, which is why we have to pay very close attention to our order of operations. What it states is if I have A times a quantity, B plus C, if I distribute that A, I can distribute that A to both terms. So it'd be A times B plus A times C. And these will give us the exact same answers. Now why? Let's look at an array of 3 rows and 6 columns. So here we have it. And we know that 3 rows and 6 columns gives us 18. Now let's see why we could do the distributive property. So let's say that instead we take the 6 and we split that into 4 yellow circles and 2 blue circles. Now if I just replace the 4 plus 2 in my statement with 6, I'd have 3 times 4 plus 2. Now think about what that means. That means I have 3 rows of yellow, each row having 4, and 3 rows of blue, each having 2 blues. Now if I just change that then, I'd say I've got 3 times 4 rows, or 3 rows times 4 yellows in each, plus 3 times 2 blues in each. I have 12 yellows and 6 blues, and I have 18 total circles. Now you can have different variations of the distributive property. I could have the quantity in the front being added times C, and again it'll do the same thing. I just distribute backwards. So I could distribute the 2 to both 4 plus 3. It'll give me the exact same solution. I can also distribute to more than just 2 terms. I could have 3, 10, 20 terms, it doesn't matter. I can distribute to every single one of them. So say I have this expression, I can multiply every single one of them by 2, and it'll give me the same simplified solution. And then the last one, my quantity can also be subtraction. I just have to remember that when I get down to my final step, I have to subtract left to right. So if I have 5 times 6 minus 2, or the quantity 6 minus 2, I can distribute the 5 to each term, multiply, and then subtract. Now I can use this to help us simplify expressions that may be a little bit more complex that I don't know the large multiplication for. For example, say I have 32 times 25. That's kind of hard to work on top of my head, especially for young students. But what I could do is I could split this into 2 values that are a little bit easier. Instead of dealing with 32, I could deal with the quantity 30 plus 2. That's the same value, but using the distributive property, I can distribute the 25, and that's a lot easier to work with. Because 30 times 25, I know I can do 3 times 25 is 75, add the 0, because that's like multiplying by 10, and then I've got 2 times 25 is 50. Much easier. And then 750 plus 50 is 800. Same thing if I had something like 28 times 25. I could either do the same thing, say 20 plus 8, the quantity 20 plus 8, or I could say the quantity 30 minus 2. Then I distribute my 25 again, and we already know that 30 times 25 is 750, and then 2 times 25 is 50, and give me 700. So I can break numbers apart and use those quantities with the distributive property to be a lot easier. I can also extend out my distributive property. If you remember, just a minute ago we talked about the fact that you can multiply backwards to quantities. Now say that I want to split that quantity that's multiplied into an addition quantity as well. So let's look at this. We know this is true because it's one of our variations. Now say I just plug in the D plus E, the quantity for my letter C there. When I can now distribute my A and my B to both of them, and you'd have A times B plus A times E plus B times D plus B times E. A lot of you probably learned this in high school under the name of FOIL, first, outer, inner, last. The thing to remember those, it doesn't have to just be two terms, it can be multiple terms, 3 or 4. But let's look at an example of this. Say I have 3 plus 5 times 7. Now if I did it just the typical way, I distribute my 7, I get 3 times 7 plus 5 times 7, and I end up with 56. Now say instead I want to split my 7 into 6 plus 1. So we go back to this step. See, we've already distributed the 7, both of them. But I can replace that 7 with the 6 plus 1. And now I'm going to distribute forward. So I get 3 times 6, 3 times 1, 5 times 6, and 5 times 1. And I just keep simplifying now. 18 plus 3 plus 30 plus 5. And now I'm at all addition. I can add in any way I want using associative and commutative properties. But I can end up with 56 as well. As I just said a minute ago, we can extend beyond just 2 values. Say I have 3 values in this one case. Now an easy way to look at that is to say first, here's my quantity. I'm going to distribute that. So I've got 4 times the whole quantity plus 5 times the whole quantity. Now I can distribute the 4 to all 3 of those terms and the 5 to all 3 of those terms. And using commutative and associative property, I can start to simplify. And I would end up with 107.